So, hey, Melanie, today I wanted to discuss an important global issue that's concerning our marine ecosystems. And this issue is climate change. So, compared to the 1700s, the pH levels of the ocean is approximately 30% more acidic than in 2017. And this depicts how the issue is gradually getting worse and worse every year. So this leads to me to my first question, and that's, how does climate change affect the coral reef ecosystem and the ocean chemistry?
Okay, so we know that ocean acidification changes the pH of ocean water. And because marine life live in the ocean, there's going to be changes to marine life, like on the organism scale, so actual individual organisms. These can be even fishes and invertebrates like corals as well, in addition to just the environment, so coral as a habitat. So we know that with this change in ocean chemistry, we can expect it to be difficult for corals to calcify, which means that when corals are larvae, it's called a coral planula. When they settle, it's actually a soft body larvae that has to get the calcium from the ocean water to basically make that hard skeleton. Now, that if there's a change in ocean chemistry, it's going to be harder for corals to calcify. So it's going to be harder for corals to grow, and with less coral growth, there's less reef habitat for other organisms that live on the reef to live in. And so that's definitely a concern for a lot of marine biologists.
Yeah. So how does this cause ocean, like through the processes, how does this cause ocean acidification and coral pollution? Can you tell me some of how the carbon dioxide enters the ocean?
So we know that with excess carbon dioxide in the atmosphere, they call it a greenhouse effect. And it's because whatever is in the atmosphere will enter the ocean either through wave action or just movement of the surface waters of the ocean. And that will add naturally carbon dioxide into the ocean water. There's a natural carbon buffer system, right, that the ocean has done for longer than any of us have been here, basically, since there was an ocean on this planet. But what's happening is, since there's excess carbon dioxide, it's throwing off that chemical reaction. And so you'll have that difference in that regulatory process of ocean water. And what makes the atmosphere warmer is just that excess hydrogen that is in the ocean. Because between the ocean and the atmosphere, or the air on this planet, there's going to be kind of this back and forth, because the chemical balance of these elements are always kind of waxing and waning. They're always going back and forth. And so when there's excess hydrogen in the ocean, you're going to have warmer atmosphere waters, because you can't separate those two planes. We like to think of what's going on above the ocean as separate from the ocean, but it's just one planet. And so whatever is affected in the ocean is going to affect the air, and vice versa. Yeah.
So does this issue normally increase or decrease pH levels in the ocean? So in other words, more alkaline or acidic? And how does this usually happen?
So what's happening is, your pH scale is basically, this from alkaline right to acidic. We think that what's going to happen is it's going to be more acidic. Okay, so that could affect corals specifically and how they grow. It could affect other marine life animals like plankton, and how they actually are able to, again, make their hard shells like crabs and lobster. These are all animals that rely on ocean water to build their skeletons, including coral reefs. Yeah.
So how has the pH levels increased in the past few decades, and what effects does this have on our local coral reefs, such as those in Hanauma?
So pH is going down, which means that it's more acidic because of the pH scale. When things are more basic, like if you think of milk is a pH value of 8. Coffee is more acidic than milk, so that's more of a pH value of, I think, 4. And so we know that pH is going down, and with that, we don't have 100% understanding of how that's going to affect coral. We expect that because of changing water chemistry, the coral will have a difficult time calcifying or making its exoskeleton, right? This part here, all that you see here, this is all calcium, and so, but we also think that what's going on too is just because the atmosphere is warmer, it's making the waters warmer too. And so we'll have like warmer waters, which will intensify coral bleaching, because corals are happy and healthy at a certain temperature range, and if it's too hot, they're kind of like a Goldilocks species, not too hot, not too cold, just right. Corals are the same. If it's too hot for them or too cold for them, they will bleach, which means that they will expel their symbiotic algae that resides in their tissues. That symbiotic algae is very important because it provides the coral host nutrition. And we think about 80% of the nutrients that are derived from photosynthesis through this algae partner relationship with coral, provides 80% of their energy to them. So basically, they need it, and if they bleach it out and they don't have it, then even though a coral can regain its symbionts later when temperatures are right and it's happy and healthy, there is a concern that when it's bleached, it could die. And once, this is a very slow-growing animal, so we're always very concerned about that. How that affects organisms here at Hanauma Bay is basically very similar to how this would affect other reef-dwelling organisms. Coral provides a home, a habitat for all of the marine life that you see in Hawaii and other areas of the world, like the Caribbean, that have coral reefs. Without a home, you're not able to live. Yeah.
So throughout my research, I've learned that with ocean acidification, corals cannot absorb calcium carbonate. And that's required for them to maintain their stony skeletons. And so, but if we can somehow provide and increase the calcium carbonate directly through the corals, to the corals through human processes, this may work. So do you think this is a viable solution?
So historically, when humans have intervened with natural processes of the earth and animals, it hasn't been the best result, but there are many researchers who believe that if there is no human intervention, we will lose our coral reefs. And in many nations in the Pacific that rely on coral reefs for food and for industry, this is a big concern. Hawaii is part of the United States, right? We're the 50th state. So we are not 100% dependent on our coral reefs for food, right? But other Polynesian or Pacific Island nations are dependent on that. And so there is a debate whether or not humans should intervene in whatever way. Whether that be creating supercorals, where you're trying to find that perfect combination of symbiotic algae and coral hosts that makes it more robust to bleaching or can withstand bleaching. So whether that be creating a new coral host symbiont, creating a supercoral that Dr. Ruth Gates at the Hawaii Institute of Marine Biology is currently working on, or another type of human intervention, can receive a lot of attention because we're very apprehensive to to play around with nature that way, but the bottom line is, if something is not done, we will lose these coral reefs. And these island nations that are dependent on it are going to suffer.
So generally speaking, is there a practical solution then for the acidification and bleaching? Because lowering carbon dioxide in the atmosphere can help with the acidification. So in your opinion, is there another solution that way that we can help?
I think we've come a long way. I mean, this is before your time, before my time actually. But like in the 60s and 70s, we didn't believe there was a hole in the ozone layer. That was still a very hot topic that people debated. And pretty much by, the 90s, it was accepted that, yeah, there's this hole and it's because of all this carbon dioxide. I think global climate change is a very similar process, that it will be debated, but eventually what's going on in the atmosphere cannot be ignored. And so I think the most effective campaign would be like globally, just to know, like, reduce your carbon footprint. How do you do that? Well, there's little life choices that you can make that actually contribute to that. Choosing products instead of aerosols with lotion, for example. Those little changes to your lifestyle all help with reducing the amount of carbon dioxide that's in the atmosphere. It sounds crazy. It sounds like it's not going to help out, but even carpooling, promoting sustainable energy rather than fossil fuel energy, that we know fossil fuel energy is great. We've survived on that for a long time, but it does have a pretty significant effect on the atmosphere. So having a combination of the two, like with green technology that doesn't have much of an impact on the atmosphere, and fossil fuels, is something that we could strive for. But I would recommend just simple life choices. We're consumers, right? We go to the store and we buy things. If you know what you're buying and it has less of a carbon footprint, even though it costs a little more, I think if more people purchase those items, eventually it's just going to be the standard. And that's what we need. We need to standardize our thoughts about global climate change and how we can reduce our carbon footprint.
So this leads me to my last question. If this issue is not resolved in the next few decades or possibly the next century, then what factors can possibly happen in our ocean, environment or the ecosystems?
We're definitely going to have a change in the ocean environment and the ecosystems and habitats that are underwater. We may, worst case scenario, we'll lose coral reefs and have a different type of habitat that would be created, of where the coral reefs used to be. So when coral reefs are overgrown, when they die, they can be overgrown with algae, for example. So the structure will still be there, but how that habitat functions will be different. Because if it's just an area that has a lot of algae in it, you may or may not have the same species that commonly reside in corals. And so there will be a drastic change to the environment. And whether or not that be beneficial to humans or not, that can be debated until people run out of air in their lungs to talk about it, But I think that those type of changes will be drastic for, again, island nations who are dependent on the reef for food. They may not have enough food, basically, to support their nation. Even here too in Hawaii, we eat a lot of fish here, and any change in the reef environment will affect the abundance, so how many fish you see on the reef, and the diversity or the many different types of fish that you see. And this is not only fish, this is also like our octopus and other invertebrates that people like to eat. So it's a big concern.
Well, thank you for your time.
Thank you. Thanks.